And now that's a more descriptive title, right?
What?
That's a more descriptive title.
Oh, I don't know that click wallpaper to show desktop items. We'll pretend it's not there. All right. Hello, everybody. We're here to talk about the newly announced product we had, Alloy. We're going to dig into it, and we're going to talk about it a little bit. And at a high level, Alloy is Grafana's distribution of the OpenTelemetry Collector. And as we've discussed, I am Matt with 2T's Durham.
I'm Paschalis.
And we're senior software engineers here at Grafana.
So we can start with short history lessons, not 2,000 years like we try to do, but with Grafana Agent, like initially developed as a Prometheus light alternative for the edge, like an easy way to get your metrics in a lightweight way. And eventually it evolved into adding logs with support from OTel, and then bolted on traces using like some OpenTelemetry concepts. But it was really successful for like both hobby small users and huge corporations. But this didn't come without challenges. At some times, like Grafana Agent felt like 3 disparate products instead of one in a single cohesive vision. The YAML configuration was easy to mess up with and break things, especially when you're copy-pasting things from different teams. And the OpenTelemetry concepts that we wanted to support weren't like really playing super nice with what we had from Prometheus or Loki. So we thought that things could be better. We could standardize around a single way of deploying the agent close to the infrastructure and make your lives easier. So with this, Alloy was born.
All right, so we sought out to take the best of OpenTelemetry and take what we had Prometheus and blend it together to make what we're calling Alloy. And Alloy, it's inspired by OpenTelemetry pipelines, which you may be familiar with. So we came with this idea of all these lessons learned, but to do that, you need to talk with protocols. You need to talk with backends. So we took all the traditional things you love from the agent, Prometheus, Loki, Tempo, Pyroscope, and we added OpenTelemetry, and then a little bit of Kubernetes for good measure. Now granted, this alone is not enough. You need to actually get data. You need to get telemetry. So we included batteries. We included exporters from the community to make it to where you could easily enable with one application the ability to get data from Windows or Linux or your favorite cloud provider.
So what do you think are the defining features of Alloy that set it apart from like Grafana Agent?
I think our Alloy runtime configuration is kind of one of the key features and differentiators that makes it a step above.
Yeah. So today we're going to go about these Alloy basics and how Alloy actually works and is configured. We'll go about what we mean by our Kubernetes integration and talk about our relationship with OpenTelemetry. As we mentioned in the keynote, we're continuously investing towards that relationship. Our Apollo product is standardized along OpenTelemetry. All our databases can ingest OTel natively. And we're really working with the upstream community in our components to both like package them in a nice way, but also give back to the community. And finally, we're going to go over some advanced concepts about new, exciting stuff that Alloy can do for you. So with that, let's start with the Alloy configuration syntax. There's just 3 primitive things to keep in mind. There's attributes, like key-value pairs, that are backed by a type, and are type-checked at runtime. There's expressions that really make programmable pipelines. They're dynamically computed values that propagate through all components that they touch and are used to like compute values called functions from Alloy standard library, perform logical or mathematical operations, and wire components together. And finally, we have blocks, which are groups of either nested blocks or other expressions, and which are used to configure components.
Now, if you take these kind of low-level concepts and wrap them together, you get components, which are our basic building blocks in Alloy. A component, it strives to do one thing and do it well. It has a set of arguments and a set of exports. So at the top here, you can see we have a local.file. That's the type of component. And every component within Alloy needs to be unique. So that's where we add a label, credentials. You can see here we have file name and isSecret, which are arguments you pass in. And then at the OTel collector, auth, you can see that we are passing the output or the export from a component into this token argument. So this chaining together of components can form what we like to call the pipeline.
And what Matt showed is a declarative syntax for a living configuration. When talking to customers and users about their use cases, when moving beyond the toy model approach, we found that often what they did was extremely similar to an extract, transform, and load an ETL pipeline. So they needed more. They needed pipelines that could branch out, that could be programmable, that would be highly configurable and interconnected. So these components build this sort of graph that propagates values dynamically. So for example, in the previous example, the local file component would push the new contents to the bearer token authentication mechanism whenever its file contents changed, while here, the discovery HTTP and discovery Kubernetes would dynamically concatenate the targets to pass on to Prometheus scrape, which would, again, scrape those targets and push these metrics out to a remote write endpoint. So maybe see this in action? What do you think?
Absolutely.
Yeah, let's go. So here you can see the UI of a misbehaving Alloy instance. I can immediately see the list of components that I have. I have some Prometheus components, some discovery components running, and some OpenTelemetry Collector components. I can see their health status, and with the view button, I will be able to go to their details page. The graph view clearly shows two pipelines running in parallel in a hybrid environment. An OpenTelemetry Collector pipeline with a receiver, a processor, an exporter, and the Prometheus pipeline running side by side, which again dynamically concatenates these targets for discovering services and pods from Kubernetes, scrapes those metrics, and pushes them out to a Prometheus remote write endpoint. It also uses a remote. Here, if I go to the Kubernetes service discovery, I can see.
You might have lost your mic.
Thank you. I can see the list of targets that are actually being run at the very moment. So if I click on the misbehaving component, I can see exactly why this is. So I can see that Grafana Cloud credential Z not found. And here in the arguments, I can see the latest configuration. So I see that I have already gone on to fix the configuration error. So in the next polling cycle, the component would pick up the correct secret and continue sending metrics normally.
So we talked a little bit about Kubernetes because it's such an important aspect of developing in the cloud and kind of next generation development. And with the agent or Prometheus, you might be familiar with the operator. And the operator is an orchestration framework that configures whatever service it's kind of handling and sets it up based on responses from Kubernetes. And we had that for the agent, and it felt like an additional level of friction that kind of was a pain point from both development and deployment. Whenever we had to add a setting to the agent, we had to also kind of promote it through the operator. So we looked at bringing in what we call native Kubernetes. And we'll talk about those components here in a bit. But we have built several Helm charts, some that are more vanilla and some that are more opinionated. And I'd like to talk about the more opinionated one that focuses on annotation-based discovery. This is very similar to how the agent operator worked before, the Prometheus agent operator, but allows you to automatically start scraping things based upon annotations. So this really enables if you have like an infrastructure team that's handling Alloy, and you have a credit card processing something that wants to be deployed. And that team can just deploy that service. And if they add the right labels, within minutes, you'll start receiving telemetry data from those. And we think this really empowers those teams to push things forward and stops your infrastructure team from being a major blocker. So that really is one of the drives you're going to see consistently here, is not only from a technological side, but also thinking how you live and do maintenance while running Alloy.
And similarly, our years of experience of running telemetry collectors at scale, for example, in very churny or very big Kubernetes clusters, we have some components to deal with stuff like that. So we saw that service discovery can really impact the Kubernetes API. So we have a kubelet component that can perform service discovery just from the local node to reduce the overall load on the control plane. For more security-focused people who don't want to run like as a daemon set with extra security privileges just to get logs, we have a component that can get Kubernetes logs over the network and avoid using like daemon sets and deploy a simple stateful set instead. We have also found that people like CRDs, so we have like components that can read from CRDs, either service monitors or pod monitors, or to sync like recording rules to Mimir and Loki. And we found that this is like enabling new use cases for people.
Paschalis, you mentioned getting away from daemon sets. What is like some reasons you would want a stateful set over a daemon set?
Well, the main benefit that you get is like more fine-grained resource consumption. You don't need to worry about like potential noisy neighbors problems, and you have much finer-grained control about what resources you need to start your Alloy instances with.
So let's move into the OpenTelemetry phase. So you can very broadly think of Alloy as the agent plus OpenTelemetry that gives you Alloy. Again, we're trying to take things that don't normally work together, Prometheus, OpenTelemetry, Alloy-native components, and combine them in a way in which they can not only work together, but create these programmable pipelines that we think is incredibly powerful.
So we're trying to make sure that wherever you use like the Grafana agent or the OpenTelemetry Collector, again, you'll feel right at home. This means that you can bring your OpenTelemetry Collector configuration and convert it to an Alloy configuration syntax file that you can just run. There are components that you can use to convert signals from like your Prometheus pipelines to OpenTelemetry pipelines and have them flow downstream from there. We're keeping in sync with OpenTelemetry Collector releases, and we're keeping the same defaults, the same naming conventions, so that you can like mentally transform ideas from one place to another. But also what we found is that this allows you to take advantage of the dynamic nature of Alloy's pipelines, alongside what you currently might be using with the OpenTelemetry Collector or what you might intend to use. So I think that was a pretty broad statement. Maybe let's see a demo.
Let's take a look. You can see here, we've got some components going on. We've got a receiver that's going to receive some OpenTelemetry. We got a batcher that's going to batch it up. And then we have the exporter that's going to send it along. So this is pretty standard, OpenTelemetry pipeline, nothing fancy. But there at the bottom, you can see we have this remote vault, and that's an Alloy native component. So here I am, I'm running this locally. And I got an environment variable that I'm pulling the token to authorize myself against the vault. And for demo purposes, I'm rereading it every 10 seconds. Then you can see where I'm using those values, those exports, to get the username and password. And what this allows me to do is instead of hard-coding this configuration in the configuration file for these sensitive secrets, or putting them on a file on disk, instead I can have one centralized location. Now if you look here, we refresh the token, and I notice there's a problem here. The auth isn't working. You can see I'm getting this exporting failed. There's some problems. So I'm actually going to log in off screen here to my Vault instance. I'm going to update the username. I ended up adding an extra character where I shouldn't have. And then I'm going to come back here, and we see refreshing token. We see it evaluated, and no error is recorded. Great. It seems like everything's working, and I didn't have to go in and change that configuration. But just to check, I'm going to log into our App Ollie dashboard. It's a very simple app I'm running here that just rolls dice on command. I'm going to check my traces, make sure I'm getting some traces. Yep, looks good. And then I'll get a little dashboard, check it out. That's automatically generated. That's handy to have. So this combination of marrying Alloy with OTel or Prometheus into one kind of overarching ecosystem that can communicate with each other is one of the driving goals behind Alloy. It's these blending of things that not only gives Alloy its name, but also its purpose.
I think what's really interesting here is that you can use components to actually combine them in ways that we didn't expect for you to build novel use cases without having to have a dedicated feature developed for you in the Alloy or the OpenTelemetry Collector repo. Okay, so we can also discuss some things that we're passionate about, some more advanced Alloy topics, and the three things that we have for you today is clustering, modules, and a sneak peek of an upcoming fleet management solution. So should we get started?
Let's rock.
Yeah, let's go. So we hinted at this in the keynote about how Alloy supports clustering. And this means that Alloy instances can discover one another, perform graceful workload distribution, and also high availability at the same time using clustering. This enables you to have dynamic scaling, say throw the pods behind a horizontal pod autoscaler, and they can scale up and down to meet demands at all times. All instances must use the same configuration file, and this means that it's much easier to deploy than, say, a hash mode sharding solution where you have to manually go change the configuration of each specific Prometheus agent instance every time you want to scale up or down. On a technical level, under the hood, this works using streaming HTTP2 connections and works on a gossip-based eventual consistency model. We found that clusters of up to 100 and 150 Alloy instances can converge within like a second. And it also uses a consistent hashing algorithm so that Alloy instances can calculate ownership. Which things am I responsible for scraping? Which things am I responsible for getting logs out of? And this ownership is dynamically recalculated every time the cluster changes or the list of targets changes. And this is how it ties into Alloy's dynamic nature. So every time a node is declared dead or announces its intent to leave due to being descheduled, let's say, for example, or a new node joins, all instances will recalculate ownership individually and arrive at the same result. This means that internally it has been roughly 50% cheaper to run at hash mode sharding with high availability pairs, like multiple replicas, and is currently available for all pool-based workload components. So you can scrape like Prometheus metrics and Pyroscope profiles. You can use to scrape with operator components to scrape metrics based on CRDs or get logs over the network. But we're also looking to make it as a de facto way of scaling Grafana agents. So you won't have multiple options. You can have one option that works reliably and works all the time. For push-based models, you can use the same scaling mechanisms that exist in the OpenTelemetry Collector, of course, like the load balancing exporter. We have components that enable this as well. So in the future, we're looking to like converge these two situations into one solution that's great for everyone.
Paschalis, the previous agent, its scraping service mode, required console or etcd to handle configuration and membership lists. Does the Alloy have that dependency?
No, and this has been like an explicit design goal for us, that you don't have to deploy any extra moving pieces, but Alloy instances can take advantage of their dynamic nature to do it all on their own.
So let's talk about a topic near and dear to me, which is modules. So I talked a little bit earlier how components are the basic building blocks. Modules are blueprints. Modules allow you to create custom components that consist of other components. And just like regular components, they have inputs and outputs. And they allow, annoyingly, they allow the chaining of things together and the encapsulation of complex functionality in just a few lines. So if you have, let's say, 1,000 lines of log rules that you need to handle, you can instead encapsulate those into one module that then you import into your project, and you're only, from a configuration standpoint, you're looking at only a handful of lines. Now, modules, they allow you to they can pull from any sort of string, files, Git, S3, HTTP, and that is very powerful because you could even pull them from Vault if you wanted to. Now we are taking we're taking the best modules that we've developed through Agent, which had a similar feature, and we're putting them in a community repo that we invite you to take a look at, use, and add your own. We really want this to be driven by the community, by your needs. You all deal with the telemetry data more than we do. So definitely take a look at that URL and get back to us. And again, the updates are applied automatically, which we'll come here in a bit and see how that actually functions. All right, so this is a configuration file. At the top, we have the import.get that tells me I want to import a module from a get re. Oh my gosh. All right, give me 1 second here. I thought I turned no notifications. Apparently I did not. Well, got rid of everything but that thing at the top. So we'll go with it. I don't know where I'm at in this demo, but we'll pick it back up here. You can see on the logs.filter agent, that's where I'm instantiating the custom component. And I'm writing to the Loki default receiver. We can skip that Loki.write default. And then I'm using at the very bottom at the logging. This is what a module looks like. So at the top, you have a declare, and that is how you declare a custom component. You have an argument at the top, write to. At the bottom, you can see what we're exporting. And then in the middle is kind of the meat of the module, where you're handling what you actually need to happen. So here I'm adding a static label, and I'm dropping some labels, depending on what is matched. Now, let's pretend I realize I'm going to go here. I'm going to look at some logs. And I pull up a log, and I look at it, and I realize I did not add the host name. And that's really important when you're trying to figure out a problem, is where this is actually happening. So since I'm using modules, I can go off screen here. I can update the Git repository and the Git file that I just pulled from. And I'm going to add the host name using one of our constants, host name. I'm going to commit, add, check-in. And you can, again, have all of these actions be gated by your normal Git behavior. So you can have a process there that's built into Git. And then if I go and refresh the file and see if the changes occurred, you'll see I've added host name. All right? So we'll give it, there could be some caching here. So we'll give it just a few seconds here to make it automatically pull. And then if I go to refresh my logs, we should see hostname Aspen. Now, what this unlocks is the ability to do GitOps development. And we have found that that is transformative because it's easy to update the config on a device if you only have 10 of them. But we have instances where people are running hundreds of thousands of agent and alloy instances. And going to each one of those and adding some configuration is incredible overhead. And in some cases, it can take months. And oftentimes, you're not even on boxes that you own as an infrastructure team. So that's even more red tape that you have to get through. So let's say, for instance, you had needed to add something to redact credit cards. We just recently added a Loon processor, which will automatically find credit cards and add redacted to it. And the ability to go in there and to add that, and within minutes, all of those hundreds of thousand instances are now redacting without you having downtime, having to go to configuration, or having to update anything, is one of the key features that we're really focusing on beyond just the technical part. We also want to unlock and enable the teams to have agency and empowerment over their changes.
A big shout out to the community who have already contributed a lot of cool modules. So do feel free to check out. And also feel free to contribute your modules, like for things that you think are worth spreading around.
Cool, the clicker stopped.
So finally, as a natural evolution of that idea, we're going to tease an upcoming fleet management solution that we're working on Grafana Alloy. It will allow you to assign remote pipelines remotely, dynamically, to your running Alloy instances based on a set of metadata, so that you can tag individual Alloy instances as like running on OS equals Windows, and a specific set of pipelines will be applied to it. It will also help to get a centralized debug UI for people. All this is going to be based on an open source protocol that is going to be available alongside the Alloy repo, and it's probably coming soon. So with that, that was all from us for today. If you have more questions, feel free to meet us in the hallway, come chat about Grafana Agent, Grafana Agent Flow, or Grafana Alloy. We'd love to hear your history, your experience, and how you think about this new announcement, how you plan to migrate. You can join us at our community forums or the Grafana public Slack in the Alloy channel. And with this, let's enjoy the break.
Thank you all.